Hello, grade 11 students. Welcome back. Mr. L here once again. On to our next part of our project. At this point, your project should be looking very similar to mine. Maybe you have some of your own visuals in there. But what you're looking to have is an actor who has keyboard interactions, who can shoot different types of weapons. And you'll notice I made mine move a little bit faster here. That's okay. You can adjust yours as you see fit. And then we have some asteroids moving and wrapping around the world, but we can't interact with them yet. We're going to fix that in this tutorial. When I head over here into my code, I see that I have only my asteroid class open on the screen for now. I'm actually not even going to look at these other classes for now. I just want to work in the asteroid and let it know what to do when it comes into contact with a weapon or a projectile that's been shot into the world. Before I do that, I need to set up the health state for this object. So far, health doesn't do anything. We have a getter or an accessor for the health, but health doesn't even have a value yet. We haven't set that up. And so something I'm going to do here is I'm going to create a new method. I'm going to call this my SetState method. And this is what's going to set the initial values for this asteroid. And I'm going to do this in its own unique spot because maybe later on I want to have customized states for asteroids and some customizable interactions here. And in fact, one thing that I am going to do is in my project, I had initially changed the size of my ship. Your project might not be able to see that. I'm going to use a number called int size. Oh, I'm going to roll over that. Oops. To be able to do some customization for the size of my ship itself. So when I run this set state, I'm going to be setting the size. And here's how I'm going to be doing that. I'm going to create a Greenfoot image. For now, I'll call it this image. And I'm going to run this method in actor class called getImage. This allows me to pull the current visual information for this actor and assign it to a new Greenfoot image. Now I have access to this spaceship image that I put in the first place. Now what I'm able to do is take this image and scale it. And I'll scale it to the size. Oh, sorry, here we're doing the asteroid, so it'd be the asteroid image, but the size that I want it to be scaled to. You'll see in my hero class that I've done this in a similar way where I scale this image in my code here to size 50 by 50. I could make this a lot bigger if I wanted to have my spaceship be a lot bigger, but I like mine being smaller, which is why I did it in that first place there. At some point, we might want our asteroid to be able to change size. So let's just add in this functionality now so that it'll work later on when we want it. So that's how we kind of put that in there. I also want to, when I set the state, initialize my health. And for now, I'm just going to set my value for health here. So health equals, and let's set it to 20 for now. That's a good number for what we're doing here. All right, now that we have health initialized, we're going to be able to actually have this asteroid be able to be interacted with and maybe even be destroyed because it has some attribute we can keep track of. Down here in my code, I'm going to create a new method called checkContact. And this method is going to be keeping an eye, watching the world for whenever a projectile touches it. When a projectile touches this asteroid, we've got to think about what should happen. Well, what should happen is that the asteroid takes the amount of damage the projectile does, and then the asteroid destroys that projectile. Or the projectile gets removed from the world because we don't want a laser hitting it and then continuing on as if nothing happened. As soon as the laser or the missile or the firebolt or whatever you have touches it, we want that to disappear from the world to kind of mimic it being absorbed or, hitting the asteroid in the real world. That's going to make our program feel a lot more realistic. So we want to access this method constantly as our program's running. We want to be checking for contact at all times. I'm going to step you through here what we do for this check contact method in the first place. We've got a couple new things going on here. The first thing that I want to do, I want to check if this asteroid is in contact with any projectiles. and then take damage if it is. We now see one of the other reasons why creating this hierarchy is so helpful. If I created missiles, fireballs, and lasers as their own separate actors, just at the first level of actor, I would have to check for contact of each of those separately, putting in 3 different sets of code to do that functionality. But because all 3 of these are projectiles, I can simply check for a projectile in general, and it will deal with all of them automatically. So it saves us a lot of time in the long run here. Here's the method I'm going to be using. If is touching. Now, this is a method in our actor class. Why don't we pull up our API here and search it out? Where did I put my API? Up here in our actor class. Is touching. Now, is touching is a Boolean. It returns true or false, depending if it is touching. And inside here, it's looking for us to check for a class. It checks whether this actor is touching any other objects of the given class, the one that we put in to send here. So, if this asteroid is touching projectile.class. Now, when we reference a class, we have to say .class after it. That's just the way that we do it in Greenfoot. And the class we're checking for is projectile. So if our asteroid is touching any projectiles, it's getting kind of crammed at the bottom. I'm just going to make some more space for myself here. Not what you want to do, but just so it's nice and higher up on your screen to see much more easily. If it's touching a projectile, here is what I'm going to do next. I need to get the information of that particular projectile. Now, there's a number of ways we can go about doing this. In Greenfoot, it can be a little bit convoluted to access it, but here's a way that we're going to access for now. We're going to see a new functionality in here. I'm going to create a temporary projectile, or something that follows the rules of a projectile, and I'm going to assign it the information of the projectile that is currently touching it. I'm going to access another method here. Get one intersecting object. This is going to return to me an object that intercepts this object. So I am going to be able to get the specific information about the object of whatever laser or fireball or missile is currently touching to be able to get that information and deal with it directly. So I'm going to get one intersecting object, and now remember in our API here it says we need the class name of this object. Well, we're dealing with a projectile. So we're going to get one intersecting object, projectile.class. And here is a small problem we're going to come across that we have to overcome here. It says incompatible types. Greenfoot actor cannot be converted to projectile. Now, we have to do a small thing here called casting. If I put a data type in front of information, I can sometimes, now there's rules that guide this that we'll talk about more in detail later on, but I'm basically saying this information that it's getting, Greenfoot's getting a bit confused about what exactly the type of information is. I want to tell it it's specifically the type projectile so that I can assign it to a new projectile. For now, exactly why this works the way that it does is not as important as just getting it up and running and functioning, but I'm casting this information to be a projectile type so that I can use its information in the proper way. All right, so now that I have access to this, if I'm touching a projectile, then gather all the information for that particular projectile. And now I can work with it. And here's what's going to happen. Once my laser touches one of those asteroids, I want it to register that that laser's damage, now remember we input the damage here as 1, is going to be done. How do we keep track of how much damage is done? Well, we have this integer up here called health, and that's going to store how much, damage it is able to sustain until it's destroyed. Currently we set that to 20. That's a lot of lasers, but remember our other weapons have different damage amounts. Let's just quickly remind ourselves what they were, at least in what I have here in my project. For missiles, it's 10, and for fireballs, it's 3. Okay, so we're going to be able to do some serious damage with the missile at the very least. Remember, we set our health up here to 20. You can change it to whatever you want as you experiment with things. I'm going to say this, that the health of this asteroid is going to, and here's a new small thing for you to see, minus equals. That means the same thing. Well, I'll show you this first. Health equals health minus. Now, what am I going to subtract from this? The temporary projectile that I'm accessing, and I'm going to access this method, get damage. How much damage does this do? This will tell me how much damage it does when it interacts. Get damage. Here's what this says. The health of my asteroid is now going to equal its health minus how much damage was done. However, there's a better way we can write this. Rather than writing health again, it's a bit redundant, I can just say minus equals. This is the same thing. Health equals itself minus the damage done by the projectile. So each time a projectile hits the asteroid, its health will be decreased or decremented by the damage of this projectile. Hopefully that makes some sense. Now, the final thing that we need to do here is that currently it's doing the damage to the asteroid, but the projectile is still going to be passing right through it. You can see there. Once this projectile has hit, it needs to be removed. We have another method we can use for this. Remove touching. Removes one object of the given class that this actor is currently touching. I'm going to, whatever that projectile is, I'm going to remove it once it touches. What should we see now in our program is when a weapon hits an object, it disappears. Let's get some lasers firing. You can see there that it hits the asteroid and it's gone. Now, for now, all that's really going on is that it is decrementing the health and it's removing that particular projectile. The health, actually, I'm going to let this run again for a sec. This asteroid that I've shot a bunch of times here. Let's hope I remember to put this method in. I'm going to hit it more and more and more. I'm going to pause. I'm going to take a look at this and see what its health value is right now. It's minus 19. So if it had 20 health, 1 damage each, that means I hit it 39 times. Minus 19. Why is it still alive? Well, it's because I haven't actually programmed in what's going to happen when its health reaches 0. I'm going to toss this under check contact because the contact is the only thing that's going to reduce its health. So it's going to check after a hit is made if health is less than or equal to 0. What should happen? This asteroid should be destroyed. I'm going to access my world and say remove object. And what am I removing from the world? This object. So if the health is equal to or less than 0, you have to do the less than also because some weapons, like if it does 10 damage and it has 5 health, it will then have minus 5 health. And if it's only equal to 0, then it's not actually going to be destroyed. It has to be less than and equal to. Now, let's see what's going on. There's something finicky going on here, which is kind of fun. Health, instructor, health, set state. Aha, here's the problem in the first place. When I set my health to 20, I haven't actually set my state. I need to do that when I construct my asteroid. So currently, actually, if I take a look at this, what's my health at? It's set to 0. I haven't initialized it, and the automatic initialization is 0. So actually, I didn't hit it 39 times. I'd only hit it 19 times. So that was an assumption I made. Glad I went back and checked this here. when I construct my asteroid, I need to set the state. And now, since we also have to set a size number, we're going to set the size to be 50 for now. So it's going to set the sizes of these asteroids to 50, and it's also going to now set their health to 20. So now, when I hit run, they shouldn't immediately disappear, but it's good to know that they actually did disappear when I wanted them to. So I'm going to shoot this poor asteroid that's currently teleporting around my screen up to 20 times, and bam, it disappears. Awesome. Let's use some of my stronger weapons, get a few shots in there, chase it down. I should have made it have less health. Let's use a missile. 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 There we go. Missile does more damage, so I've destroyed them all. This code was running successfully, checking for contact. Each time a projectile touched it, it accessed the amount of damage of that unique projectile, and then reduced the health by that much, removed the projectile from the world, and then also checked if health is less than or equal to 0, remove the object from the world. Before we're done with this lesson, I want to add one more element to this. I like when we have visual feedback in our projects. We're going to add just one more layer to this to make this a little bit more interesting. Up here at the top, I'm going to be adding one more variable here, right beside health. I'm going to call this max health. I need two different variables here, max health and health, to be able to deal with things. This also means that when I set state, I'm actually going to set my max health to 20, and then I'm going to set my current health to the same as max health. So at the start, the current and max should be the same, right? You start with full health, that makes sense in a game. But down here in my logic, I'm going to work with those variables in a slightly different way. What I want to happen in my game is that as the asteroid takes damage, I want its image to change somehow. Here's what I'm going to do. And you can feel free to play around with different ways of showing this. This is just one possible strategy. I'm going to say, if the health of the asteroid is between 1/3 and 2/3, so pretty damaged, something's going to be different. And here's how I do so. If health is greater or equal to max health times 0.33. So what I'm saying here is if my current health is more than 33% of the max health, and health is less than max health times 0.66. Let's make sure you understand this. I'm saying that if my health is above 33% of max or below 66% of max, so between 33 and 66%, in that middle range of its health, I want something unique to happen. Before I put in what's going to happen, I'm just going to add another else if for the second scenario, which is if health is greater than 0, so it's not quite dead, but almost, and health is less than max health times 0.33. So that's my second scenario. When it's just about dead in the bottom, the last third of its health, I want something else to happen. And actually, I can join these statements here because this will help the processing speed be a little bit better. If health is in the middle third, do something. If it's in the bottom third, do something. And if it's at 0 or below, it's destroyed. So what should we have happen in these different scenarios? Well, this is where you can be more creative with things. I'm just going to access a method that we have in our actor class called change transparency. Now, change transparency, oh, got some lag going on here, unfortunately. Change transparency allows me to change the transparency of an image by a certain amount. 255 is full opacity, meaning it's fully visible. That's what it's automatically set to. 0 means fully transparent, means it cannot be seen at all. So if 255 is maximum, when it starts to take a lot of damage, I might set it to 200, and when it's getting close to dead, maybe I set it to 100. And let's see if this does anything for us here. There should be an error popping up, but we seem to be having one of our normal glitches. Let's just reload this here. I'm trying to show you something going wrong, and it's not allowing me because of glitchiness. Okay, let's go back into our asteroid here. Sweet. And it's deciding to still not show us, which is unfortunate. Well, I'll just explain to you. This change transparency is a method that has to be accessed through a Greenfoot image. So I need to do kind of the same idea that I did when I set the scale, get a Greenfoot image, and then scale it in the up here, but down here I'm actually going to change the transparency. But I have a couple different places where this is happening. The best way to deal with this is a custom method. I'm going to create one called change transparency. And I'm going to send to it the transparency that I want it to change to. Now, I just want to make this really clear. This is just one example of how I can get some visual feedback from my project. One sec, I gotta sneeze. Sorry, back. It's just one way that I can get some visual feedback in my project, and there's many other ways you can do this. So instead of running this change transparency method, I'm now running this change transparency method of my own construction that then it will be able to set this transparency inside of my actual project. So how does this logic going to work? Like I did before, I'm going to create a new temp Greenfoot image, and it's going to be equal to my image, and then I can simply just take that temp image and I'm going to set the transparency to the transparency level that I input up here. Interesting. If you've been following along, what you should see, I'm gonna have to go troubleshoot in the background so I can end this video. It's already crept over 20 minutes, shoot. So what you're gonna be able to do is if you follow along with this, you should be able to see that your ship becomes more and more see-through as it takes damage. And then when it takes enough damage, it's going to be destroyed. In the next video, I'll show this actually running up and functioning. But for now, I'll let you play around with it yourself, and I want you to spend some time actually setting up some different scenarios. Try some different strategies for showing some visual feedback. And also, the final challenge for you, we have our asteroids being able to take damage from projectiles. Are you able to actually allow your hero to take damage from the asteroids? I'll leave that up for you to try and implement using some of the same logical ideas that we used with check contact in our asteroid here. Enjoy. See you in the next one.